Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the properties and formulae of 2D shapes like the rectangle, square, trapezium, parallelogram, rhombus, circle and semicircle. Mensuration is an important and scoring topic of the quantitative aptitude section in competitive exams like GRE, GMAT, SSC, RBI exams, railway exams, and so on. There are different formulae to solve questions on this topic. So, knowing and applying these formulae is very important to do well in this section. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's now understand the properties of a rectangle. A rectangle is a quadrilateral, that is, it has 4 sides, 4 vertices and 4 angles. Look at this diagram. This is a rectangle. This rectangle is a quadrilateral because it has 4 sides. They are AB, BC, CD and DA. Also, this rectangle has 4 vertices A, B, C and D. This rectangle also has 4 angles, angle A, angle B, angle C and angle D. The opposite sides of a rectangle are equal and parallel to each other. This means AD is equal and parallel to BC. Similarly, AB is equal and parallel to CD. The interior angle of a rectangle at each vertex is 90 degrees. The sum of all the interior angles is 360 degrees. Now in this rectangle, angle A, angle B, angle C and angle D are the interior angles, and each of these angles is equal to 90 degrees. The sum of all the interior angles is 360 degrees, which is obvious because 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees is 360 degrees. The length of the diagonals is equal. The diagonals bisect each other. In this rectangle, AC and DB are the diagonals of the rectangle, and the length of these two diagonals is equal, that is AC is equal to DB. Now these two diagonals bisect each other, which means each of the diagonals bisects the other diagonal into two equal halves. Now since the length of the two diagonals are equal, it clearly means that each of the halves of the diagonals are equal to each other. Let's now look at a few formulae of rectangles. Look at this rectangle ABCD. Now the longer side of a rectangle is its length. So AD is the length. Let it be L. Now since AD is equal to BC, it means BC is also equal to L. The shorter side of a rectangle is its breadth. Here AB is the breadth of the rectangle. Let it be equal to B. Since AB is equal to CD, it means CD is also equal to B. Now here AC and DB are the diagonals of the rectangle. Since the diagonals of the rectangles are equal to each other, if AC is equal to D, then DB is also equal to D. So the diagonal of a rectangle is D. So now we have length of a rectangle is L, breadth of a rectangle is B, and diagonal of a rectangle is D. Now let's look at the formulae for perimeter, area and diagonal of a rectangle. Now perimeter is nothing but the length of the boundary. Now in this rectangle ABCD, the length of the boundary would be AD plus DC plus CB plus AB, that is L plus B plus L plus B, which is nothing but 2L plus 2B. 2L plus 2B is nothing but 2 multiplied by L plus B. So perimeter of a rectangle is equal to 2 multiplied by L plus B. Area of a rectangle is equal to length multiplied by breadth, which is L multiplied by B. Let's now look at the formula for the diagonal of a rectangle. Look at this right angle triangle ABC. Here AB is B, BC is L. Angle B is 90 degrees and the side opposite to this angle is the hypotenuse. The side opposite to the angle B is AC. So AC is the hypotenuse of the right angle triangle ABC. Now we know that AC is also the diagonal of the rectangle ABCD and diagonal of the rectangle is D. So AC, the hypotenuse, is D. So now we have in the right angle triangle ABC, AB is B, BC is L and AC is D. So applying Pythagoras theorem, we get D squared is equal to L squared plus B squared, which means the diagonal D is equal to square root of L squared plus B squared. Remember these three formulae to solve problems on rectangles. Let's now look at a few properties of squares. The square has 4 vertices and 4 sides. Look at this square ABCD. This square has 4 sides AB, BC, CD and DA. Also it has 4 vertices A, B, C and D. All 4 sides of the square are congruent or equal to each other. This means AB is equal to BC is equal to CD is equal to DA. The opposite sides of the square are parallel to each other, which means AD is parallel to BC. AB is parallel to DC. All 4 interior angles are equal to 90 degrees. The sum of all interior angles is 360 degrees. In this square, angle A, angle B, angle C and angle D are the interior angles and each of these angles is equal to 90 degrees. And clearly 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees is 360 degrees. The length of the two diagonals of the square are equal to each other. This means AC is equal to DB. The diagonals of the square bisect each other at 90 degrees. This means AC bisects DB at right angles, which means each of these angles is equal to 90 degrees. The diagonal of the square divides it into two similar isosceles triangles. Now if we consider the diagonal AC, then AC divides the square ABCD into two similar isosceles triangles ABC and ACD. We get two similar isosceles triangles because all the 4 sides of the square are equal to each other. Similarly, if we consider the diagonal DB, then we get two similar isosceles triangle BAD and DBC. The length of the diagonals is greater than the sides of the square. This means AC is greater than the sides of the square. AC is greater than AB, AC is greater than BC, AC is greater than CD, AC is greater than AD. Similarly for the diagonal DB, DB is greater than the sides of the square. Let's look at a few formulae for squares. Look at this square. We know that the four sides of a square are equal to each other. So if this side of a square is A, then each of the other sides would also be equal to A. Now this is the diagonal of the square. Let it be D. So if A is the length of the side of a square and D is the diagonal of the square, then let's look at the formula for perimeter, area and diagonal of a square. Now perimeter is nothing but the length of the boundary. Now in this square, the length of the boundary would be A plus A plus A plus A, which is nothing but 4A. So perimeter of a square is equal to 4A. Now area of a square is equal to side multiplied by side, that is A multiplied by A, which is A squared. So area of a square is equal to A squared. Now look at this right angled triangle. Here this side is A, this side is also A. This angle is 90 degrees. The side opposite to the 90 degrees is the hypotenuse. So this is the hypotenuse of this right angle triangle. Now we know that this is also the diagonal of the square and is equal to D. So hypotenuse is D. So for this right angle triangle, we have this side as A, this side as A, and the hypotenuse as D. Now applying Pythagoras theorem, we get D squared is equal to A squared plus A squared, which means D is equal to square root of A squared plus A squared, that is square root of 2A squared. So diagonal D is equal to A root 2. Now sometimes in a problem, uh, only the value of diagonal is given and you're asked to find the area. Then use the formula area is equal to diagonal squared divided by 2. Now we know that diagonal is equal to A root 2, which means diagonal squared would be equal to 2A squared. Now 2A squared divided by 2 is nothing but A squared, and A squared is nothing but area of the square. So whenever the value of diagonal is given and you're asked to find the area, use the formula area is equal to diagonal squared divided by 2. Remember these four formulae to solve problems on squares. Let's now look at the properties of a trapezium. A trapezium is a two-dimensional shape with four sides, four angles and four vertices. Now look at this trapezium A, B, C, D. Now this trapezium has four sides AB, BC, CD and DA. It has four angles, angle A, angle B, angle C and angle D. And this trapezium has four vertices A, B, C and D. One pair of opposite sides of a trapezium are parallel to each other. These parallel lines are known as bases. One pair of opposite sides in a trapezium is non-parallel to each other. These non-parallel sides are known as the legs of a trapezium. So look at this trapezium ABCD. Here CD is the side opposite to AB and CD is parallel to AB. So one pair of opposite sides is parallel to each other. and these parallel lines are known as bases. So CD and AB are known as bases. Here AD and CB are the opposite sides, and these are not parallel to each other. These non-parallel sides are known as the legs of the trapezium. So AD and CB are the legs of the trapezium. The diagonals of a trapezium always intersect each other. This means here the diagonals of the trapezium are DB and CA, and they always intersect each other. The adjacent interior angles of a trapezium make a sum of 180 degrees. Now, what are adjacent interior angles? Here, angle A and angle B are adjacent interior angles. Angle B and angle C are adjacent interior angles. Angle C and angle D are adjacent interior angles. Angle D and angle A are adjacent interior angles. Now, the sum of the adjacent interior angles of a trapezium make a is equal to 180 degrees, which means angle A plus angle B is equal to 180 degrees. Similarly, angle B plus angle C is 180 degrees. Angle C plus angle D is 180 degrees. Also, angle D and angle A is equal to 180 degrees. In a trapezium, the sum of all the interior angles is always 360 degrees. This means angle A plus angle B plus angle C plus angle D is equal to 360 degrees. The line that joins the midpoint of the non-parallel sides is always parallel to the bases. Now here in this trapezium ABCD, the non-parallel sides are AB and CD. The midpoint of AB is E. The midpoint of CD is F. The line joining, and this is the line joining the points EF. Now this line is always parallel to the bases. Now here the bases are AD and BC. So EF is always parallel to AD, EF is always parallel to BC. The distance between the two parallel sides is the height of the trapezium. Now in the trapezium ABCD, AB and CD are the two parallel sides. Now the distance between these two parallel sides is the height. So this is the height of the trapezium. Let's look at a few formulae for trapezium. Look at this trapezium ABCD. Here side CD is parallel to side AB. In a trapezium, the two parallel sides are not equal to each other. As you can see here, the side CD is shorter than the side AB. Let CD be equal to A and AB be equal to B. The distance between the two parallel sides is the height of the trapezium. So this is the height of the trapezium. Let it be H. So now we have the two parallel sides as A and B, and the distance between the two parallel sides as H. Now area of the trapezium is equal to half multiplied by sum of parallel sides multiplied by distance between the parallel sides. The sum of parallel sides is nothing but A plus B, and distance between the parallel sides is H. So area of a trapezium is equal to half multiplied by A plus B multiplied by H. Perimeter is nothing but the sum of all the four sides. In this figure, the perimeter of the trapezium ABCD is equal to AB plus BC plus CD plus DA. Remember these two formulae to solve problems on trapezium. Let's look at the properties of a parallelogram. A parallelogram is a two-dimensional shape with four sides, four angles and four vertices. Look at this diagram. Here the shape ABCD is a parallelogram. This is a two-dimensional shape with four sides AB, BC, CD and DA. The four angles are angle A, angle B, angle C and angle D. The four vertices are A, B, C and D. The opposite sides of a parallelogram are parallel. So in this parallelogram, AB is the opposite side of DC. So here AB is parallel to DC. AD and BC are the opposite sides. Here AD is parallel to BC. The opposite angles of a parallelogram are equal. Here angle A and angle C are the opposite angles. So here angle A is equal to angle C. Similarly angle B and angle D are opposite angles. So here angle B is equal to angle D. Like all other quadrilaterals, the sum of all the angles of a parallelogram is 360 degrees. This means angle A plus angle B plus angle C plus angle D is equal to 360 degrees. The adjacent or the adjoining angles of a parallelogram add up to 180 degrees. So here angle A and angle B are the adjacent angles. So here angle A plus angle B is equal to 180 degrees. Similarly, angle B and angle C are adjacent angles. Angle B plus angle C is equal to 180 degrees. Angle C and angle D are adjacent angles. Angle C plus angle D is equal to 180 degrees. Angle D and angle A are adjacent angles. Angle D plus angle A is equal to 180 degrees. The diagonals of a parallelogram are not equal but bisect each other. Here in this parallelogram AC and BD are the two diagonals and these two diagonals are not equal to each other. But each of these diagonals divides the other diagonal into two equal halves. This means the diagonal AC divides the diagonal DB into two equal halves. So DE is equal to EB. Similarly, the diagonal BD bisects the diagonal AC. So AE is equal to EC. So the diagonals of a parallelogram are not equal but bisect each other. The diagonals divide the parallelogram into two congruent triangles. So now if we consider the diagonal DB, the diagonal DB divides the parallelogram ABCD into two equal triangles DAB and BDC. So DAB is congruent to the triangle BDC. If we consider the diagonal AC, the diagonal AC divides the parallelogram ABCD into two congruent triangles ADC and ABC. So triangle ADC is congruent to triangle ABC. Let's look at a few formulae for parallelograms. Area. The area of a parallelogram is equal to base multiplied by corresponding height. Look at this parallelogram ABCD. Here, if we consider the side CD as the base, then the corresponding height would be the perpendicular drawn from the vertex A to the base. So this is the corresponding height to this base. So area of the parallelogram ABCD here is equal to the base multiplied by the corresponding height. Perimeter. Perimeter is nothing but the sum of all the four sides. Look at this parallelogram ABCD. Now here the sum of all the four sides is nothing but AB plus BC plus CD plus DA. Now we know that in a parallelogram the opposite sides are equal. So if AD is A, then BC is also equal to A. Similarly, if AB is equal to B, then DC is also equal to B. So sum of all the four sides is B plus A plus B plus A, which is nothing but 2A plus 2B, or 2 multiplied by A plus B. Now, if we consider this as the base, then this side would be the adjacent side. So, B is the base and A is the adjacent side. So, 2 multiplied by A plus B means 2 multiplied by adjacent side plus base. So, perimeter of a parallelogram is equal to 2 multiplied by A plus B. Remember these two formulae to solve problems on parallelograms. Let's look at a few properties of a rhombus. A rhombus is a two-dimensional shape with four sides, four angles, and four vertices. Look at this diagram. Here, A, B, C, D is a rhombus. This is a two-dimensional shape with four sides, AB, BC, CD, and DA. The four angles are angle A, angle B, angle C, and angle D. The four vertices are A, B, C, and D. All sides of a rhombus are equal. This means here AB is equal to BC is equal to CD is equal to DA. Opposite sides are parallel. This means here AB is parallel to CD, AD is parallel to BC. Diagonals are not equal but bisect each other at 90 degrees. As you can see here, the diagonal AC is not equal to the diagonal DB, but both these diagonals bisect each other at 90 degrees. That is, AC and BD bisect each other at 90 degrees. So each of these angles is 90 degrees. Opposite angles are equal. This means angle A is equal to angle C, angle B is equal to angle D. Adjacent angles add up to 180 degrees. Here it means angle A plus angle B is 180 degrees, angle B plus angle C is 180 degrees, angle C plus angle D is 180 degrees, and angle D plus angle A is 180 degrees. The sum of all the interior angles of a rhombus is always 360 degrees. Here it means angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Let's look at a few formulae for a rhombus. Area. Area of a rhombus is equal to half multiplied by product of its diagonals. Now look at this rhombus. Here D1 and D2 are the two diagonals. So area of this rhombus would be half multiplied by D1 multiplied by D2. So area of a rhombus is equal to half multiplied by D1 multiplied by D2, where D1 and D2 are the lengths of the diagonals. Perimeter. Now we know that perimeter is nothing but the sum of all the four sides. Now in a rhombus, all the four sides are equal. So if we consider this side as A, then each of the other three sides would also be equal to A. So sum of all the four sides would be A plus A plus A plus A, which is nothing but 4A. So perimeter of a rhombus is equal to 4A, where A is the length of each side. Remember these two formulae to solve problems on rhombus. Let's now learn about another two-dimensional shape, the circle. First, let's learn about the parts of a circle. Circumference. Circumference is also referred to as the perimeter of a circle. It can be defined as the length of the boundary of the circle. Now, this is a diagram of a circle. Now, as you can see, this is the boundary of the circle. So, this length of the boundary of the circle is nothing but the perimeter of the circle or the circumference of the circle. Center. The fixed point at the middle of the circle is called the center. So, in this diagram, this is the fixed point at the middle of the circle, and this is known as the center of the circle. Radius of the circle. Radius is the distance from the center of the circle to any point on its boundary. A circle has an infinite number of radii. So here in this diagram, this is the center of the circle. Now supposing we consider this point on the boundary of the circle, then the distance from the center of the circle to this point on the boundary of the circle is the radius. Now since there are infinite number of points on the boundary of the circle, a circle has an infinite number of radii. Diameter. A diameter is a line segment that passes through the center and its end points are on the circumference of the circle. So this is the center of the circle. Now diameter is a line segment that passes through the center of the circle and the end points of the diameter are on the circumference of a circle. Let's now learn about some more parts of a circle. Chord of a circle. A chord is any line segment touching the circle at two different points on its boundary. The diameter of a circle is its largest chord. So look at this diagram. Now this line segment is the chord. As you can see, this line segment touches the circle at two different points on its boundary. Now the diameter of a circle is also a chord because it touches the circle at two different points of its boundary. And since the diameter passes through the center of the circle, the diameter is the circle's largest chord. Tangent. A tangent is a line that intersects a circle at exactly one point and lies outside the circle. Now as you can see here, this line is the tangent. So clearly you can see that the tangent touches the circle at exactly one point and the tangent lies outside the circle. Secant. A secant is a line that intersects a circle at exactly 2 points. Now here you can see that this line is the secant, and as you can see here, the secant intersects the circle at exactly 2 points. So tangent intersects the circle at exactly one point and the tangent lies outside the circle. A secant is a line that intersects the circle at exactly 2 points. Now let's know the difference between a line and a line segment. Now a line segment has two endpoints. That is, a line segment has a finite length. A diameter is a line segment because it has two endpoints. Now a line does not have endpoints. It extends infinitely in both directions. Here you can see a secant is a line because it does not have endpoints. It can extend infinitely in both the directions. Know this difference between a line segment and a line. Diameter and chord are line segments. Secant, tangent are lines. Let's learn about some more parts of a circle. Arc of a circle. An arc of a circle is the curve which is a portion of its circumference. Now look at this diagram. This is the circumference of the circle. Now this curve, which is a portion of the circumference of the circle, is known as the arc of the circle. So any curve which is a portion of its circumference is known as the arc of the circle. Segment in a circle. The area enclosed by the chord and the corresponding arc in a circle is called a segment. There are two types of segments, minor segment and major segment. Now as you can see in this diagram, this is the area enclosed by the chord and the corresponding arc of the circle. This area is known as the segment of the circle. Now as you can see, if you consider this chord, then this area is enclosed by this chord and the corresponding arc of the circle. So this area uh, is known as the segment. Also, this area is also a segment of the circle because this area is also enclosed by the chord of the circle and the arc of the circle. So we have two types of segments in a circle depending on the size. This is the minor segment and this is the major segment. Sector of a circle. The sector of a circle is the area enclosed by two radii and the corresponding arc in a circle. There are two types of sectors, minor sector and major sector. So here, this is the area enclosed by two radii and the corresponding arc of the circle. So this area is the sector of the circle. Now, as you can see in this diagram, this area is the sector of the circle because this area is enclosed by the two radii and this arc of the circle. Now, this area is also the sector of a circle because this area is enclosed by the two radii and this arc of the circle. So we have two types of sectors in a circle depending on the size of the sectors. This is the minor sector and this is the major sector. Let's look at a few properties of circles. A circle is a closed 2D shape that has one curved face. Now this is the figure of a circle. As you can see, this is a 2D shape and this circle has one curve. Can be called congruent if they have the same radius. So if two circles have the same radius, then they are congruent or equal. Equal chords are always equidistant from the center of the circle. Now look at this diagram. These two are the chords, and this chord is equal to this chord. And as you can see here, the distance of this chord from the center of the circle is the same as the distance of this chord from the center of the circle. So equal chords are always equidistant from the center of the circle. The perpendicular bisector of a chord passes through the center of the circle. Now look at this diagram. Here AB is the chord and PQ is the perpendicular bisector of the chord AB. Now as you can see here, the perpendicular bisector of the chord passes through the center of the circle O. When two circles intersect, the line connecting the intersecting points will be perpendicular to the line connecting their center points. Now look at this diagram. Here you can see that these two circles intersect at this point and this point. Now this is the line joining the intersecting points. Now this point is the center of the bigger circle and this point is the center of the smaller circle, and this is the line joining the center points of the two circles. Now as you can see, the line connecting the intersecting points is perpendicular to the line connecting the center points when two circles intersect. Tangents drawn at the endpoints of the diameter are parallel to each other. Now look at this diagram. Here AB is the diameter of this circle. PQ is a tangent drawn at the end point A of the diameter AB. RS is the tangent drawn at the end point B of the diameter AB. Now as you can see here, the tangent PQ is parallel to tangent RS. Let's now look at a few formulae of circles. First, let's look at this diagram of the circle. As you can see, this is the circumference of the circle. This point here is the center of the circle. The distance from this point, the center, to any point on the circumference of the circle is the radius. This line joining the 2 points on the circumference of the circle and passing through the center of the circle is the diameter. Now let's look at the formulae for circles. Diameter of a circle D is equal to 2r. Now as you can see in this diagram, the distance from the center of the circle to this point on the circumference of the circle is the radius. Similarly, the distance from the center to this point of the this point on the circumference of the circle is the radius. So as you can see here, this line joining these 2 points on the circumference of the circle is and passing through the center is the diameter. So you can see that the diameter is equal to r plus r, which is nothing but 2r. So diameter of a circle is equal to 2r, where r is the radius of the circle. Circumference of a circle C is equal to 2 pi r. Now we know that 2r is nothing but d, the diameter of the circle. So 2 pi r can also be written as pi d. Now here pi is equal to 22 by 7. R is the radius of the circle and d is the diameter of the circle. Area of a circle A is equal to pi r squared. Here pi is equal to 22 by 7 and r is the radius of the circle. Remember these three formulae to solve problems on circles. Let's now look at a few properties of a semicircle. Half a portion of any circle is known as a semicircle and is formed by cutting a whole circle along the diameter. The diameter of the circle and the two semicircles formed out of it are the same. So look at this diagram. This is a whole circle. Now here, this line PQ is the diameter of the circle. Now if you cut this whole circle along the diameter, then you'll get two equal halves, and each of these halves is a semicircle. Now the diameter of the circle is the same for both these semicircles. Also, these two semicircles formed by cutting the whole circle along the diameter are the same, are equal. A semicircle has one curved edge which is its circumference and one straight edge which is its diameter. Now look at this figure. This is a figure of a semicircle. As you can see here, this semicircle has one curved surface which is its circumference and one straight edge which is its diameter. Let's now look at a few formulae for semicircles. Area. Since a semicircle is half a circle, the area of a semicircle would be half the area of a circle. Now we know that the area of a circle is equal to pi r squared. So area of a semicircle would be equal to pi r squared divided by 2. Circumference. Circumference of a semicircle is the length of the arc around the semicircle. It is half of the circumference of a circle. Now we know that the circumference of a circle is equal to 2 pi r. So circumference of a semicircle would be equal to 2 pi r divided by 2, which is nothing but pi r. So circumference of a semicircle is equal to pi r. Perimeter. Perimeter is the total length of the boundary of the semicircle. Note that the perimeter of a semicircle is not half the perimeter of the circle. Half the perimeter of the circle would give us only the perimeter of the curved part, that is the arc. But the perimeter of the semicircle includes the length of the arc of the semicircle as well as the diameter. Look at this diagram of a semicircle. Now as you can see here, the perimeter of this semicircle is the total length of the boundary of the semicircle. As you can see here, the perimeter of the semicircle includes the length of the arc of the semicircle as well as the diameter. So perimeter of a semicircle is equal to length of the arc of the semicircle plus the length of the diameter. We know that the length of the arc is nothing but the circumference of the semicircle. And we know that the circumference of the semicircle is equal to pi r. And diameter is d. So perimeter of a semicircle is equal to pi r plus d. We know that d is equal to 2r. So we can write pi r plus d as pi r plus 2r. So perimeter of a semicircle is equal to pi r plus d or pi r plus 2r. Remember that the value of pi is 22 by 7. Remember these three formulae to solve problems on semicircles. Viewers, please go through this video and understand the properties of the different 2D shapes. Also memorize the formulae and be perfect with it. Please do watch our video 2D shapes solved problems part 1. If you have liked this video, please like, subscribe and share this video. Thank you.